Assalamualaikum and hello everyone. Welcome to the second video of polarity. Previously, what we have learned is actually explain bond polarity and the dipole moment. Okay, in this video, what we're going to look at is actually deduce the polarity of the molecule based on the shape and the resultant dipole moment. Okay, so if we go back to our notes on page 16 tu, okay, so to know the resultant dipole moment, first thing first, you have to know is it polar bond ataupun non-polar bond. So if it is a polar bond, then you should know what is the dipole moment. And the dipole moment is the arrow tu where the head of the arrow, the head tu must be towards the more electronegative atom. The tail tu is the least electronegative atom. So up to you nak buat partial negative, partial positive tu ke tidak. Again, dipole moment. Mana? Dipole. Dipole. Two pole tu yang we have positive pole, negative pole. So that's why dipole moment. Okay, so this is actually based on for each one of the bond itself, and then you should know lah what is actually the resultant dipole moment. Okay, so now let's apply this knowledge based on the shape of the molecule pula. We have learned quite a lot kan, from the linear until last kali kita belajar octahedral. Kalau ada lone pair last kali kita belajar is the square planar one. Okay, so on your notes ni, actually on page 17, it is not on your notes tau. Okay, this part, the upper part ni memang ada. The bottom part ni tak ada. So up to you whether you want to write it down on another piece of paper or just on a piece of post-it note pun boleh juga. Sebab the one that is available on your notes tu yang ni yang ada first CO2, CCl4 and H3. Yang ni Miss baru add. So we have talked quite a lot about the resultant dipole moment lah. The dipole moment, previous video. Okay, so sekarang ni barulah kita nak belajar what is the polarity of the molecule. Okay, so polarity of the molecule depends on the molecular geometry, which is your shape lah, and the resultant dipole moment. And we know that when it is not equal to 0, the molecule is polar. Where not equal to 0 ni, it means that the bond dipole does not cancel each other. Okay, and then when the mu is equal to 0, where the bond dipole cancel each other ni, the molecule is non-polar. Okay, so to determine the polarity of molecule, first thing first, kamu kena tahu the molecular geometry lah. Then we can draw the dipole moment. And then last but not least, barulah kita tahu polarity. Be it equal to mu ataupun equal to mu. Be it mu equal to 0 ataupun not equal to 0. Okay, so just a bit of it's just a bit of summary. So to determine the polarity of the molecule, first thing first what you have to know is actually the Lewis structure. Again, yang ini sebab tu lah, if anything, even though some of the question tu I have written down the Lewis structure for you kan, it's very important for you to try yourself. Okay, and then from there, then you should know your molecular shape. Okay, so molecular shape ni is divided into two. Yang ini baru Miss kenalkan where we have symmetry dengan unsymmetry. Symmetry ni, another name for it is the basic molecular shape. Linear, planar, tetrahedral, trigonal, bipyramidal and octahedral. So that is what we call the symmetry lah. Unsymmetry ni is actually where we have central atom, where we have lone pair on the central atom. Okay, tapi dekat sini, so simplifiedkan untuk kamu, kalau unsymmetry is mu is not equal to 0, which is polar. Tapi sebenarnya ada exception tau dekat sini. Exception dia is actually yang ni mu is equal to 0. Dia ada exception dia sendiri. Okay, tapi yang basic molecular shape ni, kalau terminal atom is identical, dia adalah non-polar. But if it's not identical, then dia adalah polar. So yang video ni sebenarnya Miss nak explain, yang ada extra notes ni sebenarnya nak explain this summary ni. Okay, so let's look here. Okay, so linear. So we have is actually BeH2. Okay, so for beryllium, again, kalau electronegativity, increasing electronegativity. Okay, apa lagi kita nak bagihin Okay, then kalau hydrogen, it is the most electropositive. So, apa lagi kita nak bagihin? Kalau ada chlorine ke, and then high electronegativity tu, it means that xenoph ni increasing electronegativity. From iodine to fluorine ni pun increasing electronegativity. So So let's look here. So again, for the dipole moment ni, our arrow tu, okay, for the arrow itself, ada head dengan tail. Head ni must be the electronegative atom. Okay, tapi dalam case first one ni, linear. A, B tu kita kan, two electron pair linear. So dia adalah, beryllium dengan hydrogen. So kalau kita tengok kat sini kan, mana ada? It's not electronegative. So which arrow yang should we be pointed towards tu? Okay, tapi again, we know that H2 must be the most electropositive. So bila kita buat arrow to itself, so hydrogen ni akan jadi kita punya tail. Sebab dia is the most electropositive. So beryllium ni yang akan jadi more electronegative. Okay, ni baru satu bond. Okay, and another one ni, from this part pun kita akan buat the same arrow. So from the hydrogen, kita akan buat kepada beryllium. Okay, dan arrow tu towards beryllium dan hydrogen kita dekat sini lah. Jadi kita punya tail. So what happened here is that, yang ini, again, as I've mentioned before, this one is actually the same as yang A ni. Because it is actually the opposite sign tau. Dia adalah, there is the opposite direction. So sebenarnya dekat sini, walaupun kamu nampak sebenarnya mu dia equal to, not equal to 0, it's actually will be cancelled out. So contohnya kalau kat sini negative 2 kan. Negative 2, positive 2. Kan equal to 0. So dekat sini, when it is linear dengan same terminal atom, dia akan jadi mu is equal to 0. So dia adalah non-polar molecule. So that is for case of linear. Okay, next kita tengok kalau trigonal planar. So again, where the arrow will be, the arrow tu will be towards more electronegative. Arrow ni nak pergi ke electronegative. Tapi dalam case ni kan ada boron dengan hydrogen kan. Hydrogen is the most electropositive. So yang ini kita akan buat arrow dia tu towards kita punya boron. But then again, kat sini macam mana kita nak tengok resultant dipole tu kan? Okay, so we know that for this part memang akan jadi yang ke bawah lah kan? For this part memang arrow dia ke bawah. Sama je. Kat sini ni buat Okay, tapi kalau between these two arrow ni, kalau kita buat resultant dipole moment dia, for this part is actually, kalau Miss punya resultant dipole moment, Miss dia akan jadi macam ni pula. Dia pula yang akan ke atas. So right now, again, walaupun kita nampak dia macam combine, so contohnya kalau sini kita nak buat, ni positive value Kalau kita kata ni positive 8, sini pun negative 8, the same magnitude. So maknanya, it will be cancel out. Okay, even though kita nampak, yang ini tak nampak cancel out kan. But then again, this is actually our resultant dipole moment. Kita combinekan yang ini. Ni resultant dia is this one. Lepas tu yang ini kan ke bawah kan. So it will be cancel out. So what happened here is actually sama juga. Mu is equal to 0. Maka dia adalah non-polar molecule. Okay, so that's for the case of trigonal planar. Ini identical atom dia tu. Terminal atom dia is identical. Okay, next tetrahedral pula. So kita tengok dekat sini. So, kita ada arrow. Again, dia, kalau ada hydrogen tu, arrow tu start daripada hydrogen towards kita punya atom tu. So, other way you want to say, kalau Miss suka macam ni je. Okay, yang ini kan. Okay, ni satu, this is one my resultant dipole moment. So, dekat sini ada satu lah. Lepas tu, kalau tiga-tiga ni, my resultant dipole moment semuanya ke atas kan. Semua arrow dia ni ke atas. So, I'm gonna do arrow dia ke atas lah. So, sama juga. So, what will happen? It will be cancel out. Sebenarnya ada another way of seeing it kalau tetrahedral ni. Okay, so sebenarnya dia macam ni. Okay. Okay, tetrahedral selalunya Miss lukis macam ni kan. Macam ni lepas tu what will happen is that, from here, kalau Miss arrange kan. Okay, kalau kamu nampak lah. Okay, between these two, between yang macam bentuk V ni, ada satu ke atas. Lepas tu satu bentuk V kat bawah ni, satu ke bawah. Satu atas. Satu ke atas, satu ke bawah Satu ke atas, satu ke bawah. So what happen is that the dipole moment will be cancelled out. So untuk tetrahedral, walaupun kamu rasa macam it can't be cancelled out lah Miss. Okay, ni satu ni ke atas from V ni. Yang ni band ni pula yang ke bawah ni. Ni pula. Ni ke atas, ni ke bawah. So actually it will be cancelled out. So sebenarnya untuk tetrahedral, where all the terminal atom is the same, dia pun sama juga. Mu is equal to 0, maka dia adalah non-polar molecule. Okay, so macam mana kita nak tengok trigonal bipyramidal pula? Okay, trigonal bipyramidal ni, so kita draw lah arrow. So, satu dekat sini. Kalau hidrogen tadi, kita tahu dia start dengan hidrogen. Nak tahu senangnya hint hidrogen ni, start arrow dia tu, tail of the arrow. Sekarang ni, we have phosphorus dengan fluorine. And we know that fluorine is the most, fluorine is the most electronegative. So, in this case around, kita punya arrow ni nak towards fluorine. Okay. Sebab fluorine is electronegative. Remember, electronegative ni adalah, it means ability to attract electron. Ability of the atom to attract electron. So, fluorine ni needs one more je kan untuk capai octet dia. So, high lah dia punya probability dia tu. High lah dia punya electronegativity. So, what happen here is that, ni lagi electronegative. Okay, kalau yang ni kamu nak fikir, nak tambah. Sebenarnya yang ini tak wajib pun nak tulis, tapi nak tulis tak ada masalah. So, it means that fluorine ni lah more electronegative. Ni lah electronegative. So, we know yang phosphorus ni yang electropositif lah. Okay, so macam mana nak arrow dia? So, kita buatlah from the phosphorus to fluorine. So, ada 5 fluorine kan? So, kena buatlah 5 dipole moment. So, we have 5 dipole moment kita kan. So, sebenarnya, as you can see here, actually, ada satu atas, there's one here kan. Satu upwards toward this fluorine, and one downwards toward this fluorine. What will happen is that this dipole moment will be cancelled out. Okay, how about this 3 fluorine ni pula? This 3 fluorine ni, maksud dia, atas bawah ni kita dah cancel out kan. Tapi yang 3 ni macam mana pula? 1, 2, 3 ni. Okay, so actually, satu fluorine ni menghadap sini. Another of the fluorine, resultant of this, okay, resultant of this resultant of this dipole moment, dia adalah, it will be towards this one. Kan? Okay, so resultant dia ke sini. So as you can see, kat sini, atas bawah ni will be cancel out. Kiri kanan ni pun will be cancel out. So sama juga untuk trigonal bipyramidal, it is actually non-polar molecule. Where it will be cancel out. So kena tulislah mu is equal to 0, then it will be non-polar molecule. Okay. Next is actually SF6. So SF6 ni, remember fluorine is the more electronegative atom. It's the most electronegative atom. So, kita buatlah arrow semua ni towards fluorine. So, ni baru satu. We have 6 atom kan. So, ada 6 dipole moment. So, what is the resultant? Okay, yang atas bawah ni mesti boleh cancel out. Macam tu je kan. The opposite direction. Okay, kalau yang this one. So, maknanya dekat sini. Okay, so kita dah tahu dah. Atas bawah ni dah cancel out kan. Okay, what will happen is that kat sini, okay, ada 4 kita ni. So, kiranya ada atas bawah ni, kira kita dah cancel out kan. Alamak, macam saya ingat pula. Atas bawah ni cancel out. Okay, so sekarang yang 4 ni, satu arrow is towards this. Kat sini, satu arrow ni kat sini pula. Opposite direction. So, what will happen, yang ini pun will be cancel out. So, sama juga for our, apa ni nama dia? SF6, octahedral, that adalah mu equal to 0 where it is non-polar molecule. So this is what is meant by kalau symmetry, where the basic molecular shape ni identical terminal atom, dia akan jadi non-polar. Okay, macam mana kalau dia adalah non-identical terminal atom? Okay, yang itu misalnya satu saja contoh, which is linear. Okay, so contohnya kita tengok dekat sini kan. Okay, so we have ada one bond, macam kiranya ada satu bonding pair, one bonding pair between hydrogen, ada satu carbon hydrogen bond dengan carbon triple bond nitrogen bond kan. Okay, so kita tengok dekat sini. For between hydrogen dengan carbon, okay, remember that hydrogen is the most electropositive. So bila arrow kita tu, tail dia tu yang akan jadi towards, it's starting from our hydrogen. Tu akan jadi start kita. Okay, so bila kita kata start dia kat sini, start dia dekat sini Okay, so dekat sini. Okay, so this is our tail. Okay, so sekarang ni between carbon dengan nitrogen pula ke mana? Okay, if you still remember, carbon Nitrogen, oxygen, fluorine. So, between carbon dengan nitrogen, nitrogen is more electropositive. Sebab kat sini sebab je lah senough. Senough. Ni increasing En. Okay, so this time around, arrow kita akan menghadap ni pula. Okay, menghadap nitrogen. Okay, so what is our resultant dipole moment? So, bila yang ini, sebenarnya in the same direction kan? So, bila the same direction, dia punya resultant dipole moment dia semua ke sini. So, is it equal to 0? It is not equal to 0. Okay, so when it is not equal to 0, we have to write down lah. Mu is not equal to 0, then it will be polar molecule. Okay, so that is actually introduction of polarity. Kita sekarang ni baru tengok yang basic molecular shape sahaja. Okay, yang ini terminal from linear until octahedral ni, semua ni adalah the same terminal. Yang ini different terminal atom. So sebenarnya senang, janganlah. There's no need for you to memorize this one tau. It's just that you should know mana arrow dia tu je. Okay, kalau contohnya ada hydrogen, remember it's starting from kita punya hydrogen. Kalau yang electronegativity ni, tengoklah. Okay, so before anything, you have to show yang dipole moment tu. Resultant dipole moment tu later. Tunjuk dulu. Contohnya BH3 kan. Kan ada 3 bond. BH3 kita ni, kita ada 3 bond. So, we have to show lah ada 3 dipole moment. Then barulah kita tahu resultant kita.